Hi guys, today I've made a video on longitude by chronometer method, also called long by chron, and this is a request of one of my very kind subscribers. So Vendu, here we go. So I've tried to explain this question as simply as I can so that you guys don't have any confusion regarding this method of calculating longitude or observed longitude and position line. Alright, and the method that we are using today is longitude by chronometer, or also called long by chron. So the question here states that on 29 November 92 in DR position so and so, the sextant altitude of the sun's upper limb east of the meridian was 28 degrees 11 minutes when chronometer error so and so showed 5 hours 49 minutes 20 seconds. If height of I was 10 meters, index error was 2.3 of the arc, and you have to calculate the direction of the position line or PL and position through which it passes. So when we say position, we basically mean the longitude, as we take the same DR latitude to be our accurate latitude. Alright, so longitude by chronometer method, or long by chron, requires you to calculate a longitude, which is the observed longitude, because the longitude given to you in the question is your DR longitude. And DR, or dead reckoning, is an approximate longitude. Now we are talking about those days when we didn't have GPSs on board ships and all, so that's why people used to navigate by an idea of the last position, and they used to take into account the set and drift and so on, and there was an estimated position that was called the dead reckoning position. Nowadays, of course, you have GPS, which is very accurate means of navigation. So what you have to do is basically calculate a observed longitude based on your sextant sight. All right, the second thing you have to remember is I have highlighted here that the question mentions that the sun's upper limb was east of the meridian. That basically means the sun was still rising. It has not reached its meridian passage, so it's before meridian passage and it's on the east of the meridian. So sun is still rising, it has not reached its maximum zenith. All right, so let's start with the question. Now we are given a chronometer time and you are given an error. Now in my other videos I've shown you how to resolve this discrepancy or confusion on how to get a GMT time from the chronometer time. So I'll quickly take you through this, but please watch my other videos where I have explained how to calculate the GMT time using the chronometer time. Alright, so in this case, of course, you have been given a chronometer time which is 5 hours 49 minutes 20 seconds, and that could also mean it's 17 hours 49 minutes and 20 seconds, because a chronometer works like an analog watch. When you see 5 on your analog watch, you don't know it's 5 in the morning or 5 in the night. And here we are talking about it from a questions point of view. Of course, on the ship, you have an idea of what your GMT might be, but in this question here, when it says 5 hours 49 minutes 20 seconds, it could be a morning or it could be evening. So let's find out. The hint given to us in the question is that the sun was still rising, so it's morning on the ship, right? So let's apply the error. So error was 1 minute 31 seconds fast, so you applied it in both the cases. When you subtract the error, because if the error is fast, you always subtract it. If it's slow, you add the error. All right, so if it's fast, you subtract it. When you subtract it, you get 5 hours 47:49, or this could also mean it's 17 hours 47:49. And then you apply your zone. Now how do you get your zone? I've shown you in the question here that you get your zone based on your longitude in time, or LIT. Longitude in time, or DR longitude given is west, which is 130 degrees and for 27 minutes west. So what you do is you take your LIT and you take your longitude divided by 15, as I've shown you here, to calculate your LIT. So when you get your LIT dividing longitude by 15, you get 8 hours 41 minutes 48 seconds. To get your zone, you round it off, and because this is closer to 9, you round it off to the next hour, which is 9 hours. Now I explain all this in my separate videos, so I'm not going to take you through all this again, because then it makes the video very lengthy. This video will focus on the long by chron method, so I'm going to skip a lot of these things which I have covered in my past videos, right? So of course, if it was 8 hours 29 minutes, then you would keep it to 8 hours, but because it's 8 hours 41 minutes, which is more than 30 minutes, it's getting closer to the next hour, you make your zone 9 hours, and it's west longitude, so you will subtract it, because if you're in the west longitude, GMT is ahead of you. Alright, all this is explained in my other videos, please watch them. So once you subtract 9 hours, so from morning 5 o'clock, if you subtract 9 hours, your zone time, which is your time on the ship, or also called ship's mean time, or SMT, is night time at 20:47, but in the question it's given to us that the sun is rising. So that means it cannot be night on the ship. It means that at the ship it's still morning. So that's why we consider the other case here, where it is 8:47:49 is the zone time or ship's mean time, and this is a morning time. So we will put our date here, given to us as 29th of November, and so our GMT is also 29th of November, because we have subtracted 9 hours from 1747:49. So that means we are still on the same day. So if it's 17:47:49 minus 9 hours, we are still on the same day, 8 hours 47:49, and that will be our SMT. But we need our GMT time. So the time that we'll be using in the question, and I'll cut this because then this is not used, is this time here, 29th of November, 17:47:49. Now many students get confused in the exam and start working with the zone time or ship's mean time. Don't do so. If you want, you can just cross it and you continue working with the GMT time. This is the time you have to choose. All right, so that's the first step. We've got the J and the GMT time. Now based on that, this is the sun. We can go into the nautical almanac for 1992. If you don't have one, don't worry about it. You can actually download it from the internet. That's what I do. I just download almanacs from the internet, especially the old ones. You can get it from the internet and go into the 29th November date. Now I don't want to take you through all that again because it makes the video lengthy. I've shown all this in my previous video, so please go and see how do you find out GHA of sun from the nautical almanac. So go into 29th November, go into 1700 hours, find out your GHA. All right, then increment can be found in from the increments pages. Increments are always added, so you add the increment and you get your GHA. Alright, so again, for those of you who may be watching my video for the first time, please go and see my other videos. I've shown there how to go into the almanac and find the values of the GHA, increment, declination, how to apply the D value of correction and then get the declination corrected, so on and so forth. I don't want to waste too much time here, otherwise the video becomes lengthy. Alright, and then you go again into the 29th November date, 1700 hours, get the declination value from there. At the bottom of the page, you will have your D value of 0.4. The declination value is increasing from 1700 to 1800, so you find out the D correction value. This is from the increments page as well for 47 minutes and 49 seconds of GMT time. So remember, this GHA is for 1700 hours. This increment is for 47 minutes and 49 seconds from the increments page. And that's why this GHA is for 17 hours, 47 minutes and 49 seconds, which is your GMT time. Similarly, this declination is for 17 hours. And this correction is for 47 minutes and 49 seconds obtained from the increments pages. And this is your declination for 17 hours, 47 minutes and 49 seconds. Alright, so that's how it works. And then you have your latitude given to you in the question. The other thing you have to find out is your true altitude from your sextant altitude. So your sextant altitude is given to you in the question, is 28 degrees 7 minutes. Index error given to you in the question, 2.3 off the arc. When it's off the arc, you will add the error, and it's minutes. Don't add it to the degrees by mistake, keep it to the minutes. You get your observed altitude. Then you have your height of eye correction of 10 meters. Now again, I've shown you where to find the height of eye correction. At the beginning of the nautical almanac, you have the height of eye tables. For the 10 meter, find out your height of eye correction, which is minus 5.6. Height of eye correction is always negative. You subtract it. What you get is the apparent altitude, which is 28 degrees 7.7. Then you go into the total correction table for the month of November for upper limb. Remember, upper limb corrections are negative, lower limb corrections are positive. Go into the upper limb correction table and then find out the upper limb value for the month of November and sun. That will be minus 17.8. Your true altitude is 27 degree 49.9 minutes. You subtract the true total correction and you get your true altitude. To get your true zenith distance, or TZD, this is true zenith distance or TZD, subtract the true altitude from 90 degree, minus 90 degrees. So when you subtract true altitude minus 90 degrees, you get your true zenith distance. Alright, that's how I got 62 degrees 10.1 minutes as my true zenith distance. Alright, Then I go into the formula here. Your formula that you can use for calculating long by chron is this formula here. So you can see what you have to calculate using this formula is basically your LHA, which is P. Alright, so once you get your P, you can calculate the rest. Now you can see in this formula here, it's given sine true altitude plus or minus sine lat or sine of deck divided by cos lat cos deck. Now this plus or minus means if latitude and declination are the same names, if both latitude and declination are north and north or south and south, you will subtract, you will use a negative sign. If latitude and declination are different names, such as south and north or north and south, if one is north, the other is south, or vice versa, you will add, use the addition equation. Now in this case, you can see that the declination was south and the latitude is north. They are different names. That's why I have used the plus sign in the equation, not the minus sign. Put in the values of the true altitude, latitude and declination. I have calculated the values in the calculator. I have restricted to 5 decimal places, which gives us a reasonable accuracy. You can take more if you want, but it's reasonable for 5. Don't keep 2, it's too less. And then you can follow the values here. If you're not getting these values, make sure you check your values. I've checked them a few times, so I know I'm correct. Alright, then do a cos inverse of what you get, such as here. And what you will get is P as 40 degrees 43.2 minutes. Now this is where it gets a bit confusing for some of the students. They don't know what to do with this. Now there is a rule of thumb that is given, and I'll also explain the conceptual method of it. Now what the rule of thumb says that if the time of sight is after meridian passage, what you get as P will also be equal to your LHA. However, if it is before meridian passage, LHA will be equal to 360 degrees minus what you get as your P, 360 minus P. Now you know that in this question here, it is before meridian passage, because we mentioned at the very beginning the sun is still rising. It is east of the meridian. It is not before, it is not after meridian passage, it is before meridian passage. So that's why whatever you get as P, you will subtract of 360 degrees to get your LHA. That is one method. Alright, now once you do that, now hint is given to you in the question, remember that. Alright, so don't think that, oh, how do I find out? Hint will always be given to you. It will be given to you whether it's night or whether it's PM or AM, whether it's east of the meridian or west of the meridian. So you know if it's east of the meridian, it's rising. If it's AM, it's rising. If it's they say it's a morning time, you know the body is rising. So that means it is before meridian passage. If it is given as PM, if it is given it's night time, or if it is given west of the meridian, you know that the body is setting now, so it is after meridian passage. So hint will be given to you in the question, don't worry about it. All right. Then you have your GHA that you calculated before as the 89 degrees 49.4 minutes. You know the relationship between GHA, longitude and LHA. If longitude is west, your GHA is the best, so GHA will be more than LHA. And this is how the equation will be written. If it's west longitude, you subtract it. If it's east longitude, you add to GHA. Now if this is the equation I've got based on my values here, I've got my LHA, I've got my GHA, I don't know what my longitude is. I can also write this equation like this here. So whenever it's west longitude, you will subtract from the GHA. If it's east longitude, you add to the GHA. So the rule of thumb is longitude west, GHA is the best. That means GHA is more than LHA. Longitude east, GHA is least. That means GHA is less than LHA. So this is longitude west, and my GHA is the best. That means it's more than, GHA should be more than LHA. Now when I write this equation like this, using simple mathematics, I can take my longitude to the other side. This is my unknown, and I will take my LHA here. This is how the equation is written. So longitude equals 89 degrees 49.4 minus 319 degrees 16.8. Now you might ask me, how can I subtract a bigger number from a smaller number? How can I get a negative longitude? Well, no, don't do that. All right, just when you see a case like this, add 360 degrees to the smaller number. When you add 360 degrees to the smaller number, this becomes a bigger number, and this is 449 49.4. And then you can subtract the smaller number, and what you get is longitude 130 degrees 32.6 minutes west. You know it's west because your DR longitude was west. That was an indication to you. Your dead reckoning longitude was west, so you know it west. The other way you can solve this, and this is a concept method, I don't know if many of you will understand this, but I thought I'll explain it to you, If you have got your GHA as 89 degrees, GHA is angle measured westwards from the Greenwich to the celestial body. Now imagine this is the GHA, this is the GHA, and this is 89 degrees. Right, 89 degrees, what was the exact value? 89 degrees 49.4. Right, and then you have your LHA, or your P that you calculated was 40 degrees 43.2. Now at this stage you are confused, you don't know what to do with it, subtract, add from 360, you can't remember the rules, so just draw your P as your LHA. P, now LHA is measured westward from the celestial body to the observer. So if you have got 40 degrees as P, use 40 degrees if you are very confused on what to do with this. Now this becomes your LHA as 40 degrees 43.2 that you have calculated from the formula. Now what is your longitude? Your longitude is measured east or west of the Greenwich meridian. This is a celestial sphere. Now in this case you can see that if I measured westward from Greenwich, and this is the west longitude, this is west, right? If it was east I would go the other way, this way, but this is west. So if you can see that the longitude measured westwards from Greenwich, in this case because you are west of Greenwich, your longitude is west. If you just add the two values, you will get the longitude. This is the west longitude. And if you add the two values of LHA and GHA in this case, you will get the same answer that you have got here. So this is a conceptual working. If you are confused with the value of P and you don't know what to do, so there are two ways you can use it. I have shown you both the ways. Use the one in which you are comfortable. So you can use the concepts if you understand the concepts, or you can use the rule of thumb of before meridian passage and after meridian passage, whatever works for you. Alright, watch this again if it's not very clear to you. I'll keep going because it's a long question, and that's why I've skipped a few steps here, so of going into the almanac and showing you how to find the values. So I'll keep going. Now the next thing you have to do is you found out the longitude. Alright, so your longitude, one part is done. You are going to use the same dr latitude, and this is the observed longitude. So the next part is finding the position line. To find the position line you have to find the bearing. To find the bearing you have to calculate A, B and C's. Now your A, B and C's are also calculated from the Norris tables. Nobody does that anymore. You can use a scientific calculator, and these are the formula given to you. You can calculate A equals tan lat divided by tan LHA. It is named opposite to the latitude unless LHA is between 90 and 270. Your case LHA is 319 degrees and more, so it is not between 90 and 270, so A will be named opposite to latitude. If latitude in this case is north, you will name your A south. Alright, so you put the values of latitude and LHA, you will get 0.58, then you name it south because it's opposite to latitude. Ignore the negative sign that you get in the calculator. Ignore it, don't worry about it. Name it south. Why? Because it is opposite to latitude unless your LHA was between 90 and 270, which is not the case here. Then you calculate your B. Your B is, you can see, tan declination divided by sine of LHA. Put in the values here. This is named same as declination. In this case your declination is south, so you will name it south. So once you put the values here, you will get 0.61. Again, ignore the negative sign, don't worry about the negative sign in the calculator, and you name it south because same as declination. Now normally we restrict to 2 decimal places. If you want, you can go to more decimal places, but when it comes to A, B and C's, we restrict to about 2 decimal places. Alright, that's good enough for us. Once you get your A and B, you have to find out C. How do you find out C? The rule is if A and B are same names, such as south and south or north and north, you will add them to get C. In this case, they are same names. If they were opposite names, you would subtract one from the other and retain the name of the larger. In this case, they are both the same names. They are both in the southern hemisphere, or the other, both are south. You will add the two and you get the answer C, 1.19. Both are south. C will be south as well. C becomes 1.19. To find the azimuth, the formula is tan azimuth equals 1 divided by C times cos of lat. Solve the denominator first. Alright, don't do 1 by C times cos of lat, don't do that. First find out C times cos of latitude, which I have. You can see, solve the denominator first. See if your answers are matching mine, they should. And then divide 1 by the denominator. Then do a tan inverse of what you get. In this case, you will get about south 43 degrees east. Some of you may get 43.1, 43.2, doesn't matter. You can keep 43 or 43.1. When it comes to bearing, remember it's a bearing, so try to keep a whole number. Unless it's 43.5 or 0.5 or so, you can't take a bearing of 43.2 or 43.3, isn't it? You can only take bearings of a whole number or maximum up to half a degree, 0.5 of a degree, right? So what you get is 43 degrees. Now we have written south and east here. How did I get south and east? So this south comes from, you are right, this C here. Whatever is C, named after C. If C was north, you would name it north. Again, my apologies, it's not S, it's C, name after C. And where does this E come from? E comes from LH, from LHA. If LHA is between 0 to 180 degrees, you will name it west. If LHA is greater than 180 to 360 degrees, you will name it east. These are LHA values. In your case, LHA was 319 degrees something minutes, right? So it was more than 180, so that's why you will name it east in this case. So once you get azimuth south 43 east, this equals 137 degrees true. How or why? It works like this. This is north, this is south, and this is east, right? This is west. South 43 east means somewhere here. South 43 degrees east, this is 180 and this is 090, so somewhere here will be 137 degrees. That's why your azimuth is 137 degrees true. To get your position line, just subtract 90 to this value and add 90 to this value. So if you subtract 137 minus 90, you get 47 degrees, and if you add 90 to 137, you get 227 degrees. That's your line, position line. That's your bearing and position line. So your azimuth is your bearing and this is your position line. So basically what this means is, if you've got a bearing of 137 degrees, this is south and east, this is 137 degrees of bearing, true, your position line is a line drawn perpendicular to the bearing, and the orientation of this line is 047 to 227 degrees. This is a perpendicular line. That's what it means. Alright, so guys, go through this video again. I hope I've simplified this. If you have any questions, just write to me in the comments below. Appreciate all of you who are subscribing to this and writing to me. I feel very happy making videos that fulfill your needs. The whole idea behind this is for me to pass on my knowledge as simply as I can, so that it helps you to understand. Again, my apologies because I didn't go into the almanac, but if you go and watch my other videos, I've shown you how to go into the almanac and find out the values of the GHA, how to find the increment values, how to apply the declination and decorrection values, and please watch them, and it's similar here again as well. All right, thank you guys. If you have any questions, shoot comments. If something was not very clear, then write to me as well, or if you want to make want me to make videos on specific topics like Suvendu suggested, feel free to let me know. All right, thanks guys, all the best with your